Welcome to Three Devs and a Maybe, the podcast series for beginner web developers and general web enthusiasts. Now, introducing your show hosts, Michael Budd, Fraser Hart, Lewis Caines, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann, and today we are very lucky to be joined by Jimmy Burrell. How you doing, Jimmy?
Oh, fine. Hello, Ed. How are you?
I'm very good, thank you, sir. We were just saying off air, actually, it's probably been a year since the first podcast we did with you.
It has been a while, yes, approximately a year.
Yeah, time has flown by. But yeah, we've been keeping in contact through Twitter messages, as me and you kind of go through the geeking out and everything, talking about all different programming languages and databases. Oh, absolutely. And I thought, we've got to get you back on. We've got to talk about all this stuff because I'm sure there's someone out there who wants to listen to this. And even not, we just have a good chat, don't we? So it'll be great.
Yes, we do. Who doesn't appreciate a good old geek out?
Well, that is exactly it, yeah. So how you doing, Jimmy? What have you been up to recently?
Oh, I'm fine. And so many things that I cannot comprehend them all sometimes. Databases, a little F#, a little Elixir, a little, thanks to you, Postgres, and a little MySQL, and lately, security.
Wow, you have been touching on a lot of areas then. That's brilliant.
Yeah, it's both good and bad, you know. It's fun, but...
So is it work related? Is it kind of like spun on by that, or is it also just your general interest?
Some a little work related. The Elixir and F# are just, my interest.
I could have picked those as being the interest ones. I can see trying to get them into the workplace. That's that you find. I find that it's a hobby project. Hobbies first, aren't they? These type of languages, and then you slowly. I mean, you've heard the stories. I'm sure, like people be able to bring them into the workplace. So it's trying to sell them on it.
Yeah, the functional programming whole paradigm. It's coming. You can see it. It's slowly moving into the workplace, and I don't know how long it will take, but soon.
That's it. I mean, and you can go kind of halfway, can't you, with just taking the principles, I find, because, when you go to these languages, like you say,
exactly.
like we're going to talk about, maybe the F# and the Elixirs and stuff, that they obviously are through and through a functional language, but, you can kind of restrict yourself in languages like the Javas, like the C#. Well, C# is actually quite good at dealing with these type of things, but, like the Javas, like the PHPs in the world and stuff, and, you can use immutability, you can use, higher order functions and things, using array maps and using these collection pipelines type things. So, yeah, you can kind of get there, and you can, slowly bring it in, like you say, but you obviously aren't going to get the full host of things without the actual language. So, yeah.
That's right.
That's it, and you're going to go back to these like languages like F# and be like, I really want to use this on a day-to-day basis.
Wouldn't that be fun? Yeah, it is. You're right. You're absolutely right. I find the concepts have really improved my whole programming outlook and programming methodology, immutability, being able to reason better about the code. But boy, it is hard to do in some languages, like especially it seems PHP, because it's not set up for immutability or many of the other things. Even map and reduce and the like are sometimes somewhat hard to pull off.
I would definitely agree with you there, and it's not the nicest syntax, bless the language, I mean, I love PHP, but yeah, it's not the greatest at that, and I mean, you go into even languages like JavaScript and stuff, and you feel like, this is much nicer, but then still, I mean, the array map and, having to pass it, obviously, this, having short closure syntax would be really nice, but I don't know whether we were getting that, speaking obviously, like whether that's a thing that's going to happen, but yeah, I mean, taking these principles, and as you say, trying to apply them where you can, and yeah, maybe sometimes you will end up with code that looks quite horrible in a language that if you then transferred that to, say, the functional language, you'd be like, oh, this is beautiful code. So
exactly,
yeah, it's weighing it up. But
I listen with interest to your Crack Joe episodes. I don't know, maybe Joe doesn't appreciate that nickname. I'm not sure, but Joe Watkins and his one recent episode, I don't remember the number off the top of my head, where he was referring to the pipe operator in the sense, and it's not exactly, it's called a right arrow pipe operator in F#, and we probably will talk about that in a moment, but it's one of my favorite constructs, even in Elixir, and So I listened to that episode and that discussion with interest, and I know some people are back and forth on that. I don't think we're going to get it in PHP. It sounds like, though.
Yeah. Well, what's your opinion on it? Would you like it as it currently stands in PHP?
I do. Would I like the pipe operator?
Yeah, the pipe operator in PHP.
Yes, I would, because I find that in doing F# or Elixir, it does help my thinking and my ability to reason, and even my ability to compose in some instances. Now, I also confess it can get out of hand.
I think that's it, isn't it? And I mean, I remember when I did speak to Joe about that, was that it is up to the developer, to use it with reason. But as you say, we are all adults. The whole Python thing of having public visibility to everything is that you should be able to be treat it well. So yeah, I mean, it's a powerful tool that you could use for good and bad. And it's whether, I mean, I'm sure actually you probably can see this in functional languages. I mean, it being used like crazy in F# and things like that with code. So yeah, I mean, maybe it will be a nice thing, but as you say, I hope it goes in personally. I mean, I do feel it has benefits. But but I do feel also that maybe just the trouble is I remember when Joe mentioned it actually, and it is that kind of understanding, that trying to teach someone that concept of the way, because everyone's been so beaten into them that it's a stack, so everything builds up of it and pop it off, and then when you actually go into this, it's like, well, actually no, this code's going to look completely different, but as you say, but whether it pros and cons of it, but yeah, well, we'll have to see what the RFC and what the voting goes on that and everything. But it's all interesting. It's all fun. I mean, it's great that, the language PHP, does still, it's got all this traction and people still use it and people still want to, innovate and, build on top of it.
Yes. A Bash user, or a Unix, I should say, a Unix user would easily grasp that concept because of his work with the command line.
Absolutely. Yeah. The piping.
But not every programmer.
But then maybe that's maybe me being bad there. We've kind of, with me and Joe's, me kind of agreeing with Joe with that. Oh, maybe that's a hard concept, but you don't actually have to use it. Again, it's something that is available. It's like one of those unlock gaming functions. Like, unlock, I can now use this and understand this. So maybe it's fine that it's in the language. So, yeah, I mean, I'm trying to think really where to start off, if there is any kind of way that we can kind of go through this in chronological order. But I think it is just kind of a couple of topics that me and you have been, kind of discussing. Like, we're like, oh, this is cool.
So true.
This is cool because, obviously you heard about my closure experience. So you're like, oh, I've been looking at Elixir, and you're like, oh, I'm looking at F#. And it's just like chucking these things around, and then databases, obviously. So I guess let's start with F#, I think is a nice way to start, and
Good.
So what drew you to F#? I mean, what kind of was your backstory with that language?
I really had no experience with it or any functional language at the time, and so I just kind of more or less went to the closest thing at hand. I just made almost a split-second decision to, hey, you know what? I've got an hour. I'm going to try some functional programming. What do I already have installed and close by? And it just so happened I was looking at my Windows box at the moment and decided to try F#. Of course, I'd heard a few things about F#, and this is kind of goes back to, I guess, the question, what is F#? I had heard that it was OCaml with .NET tagged on or cobbled on or something like that. And you do hear that answer a lot out on the web, and there's a grain of truth in that. But really, after you get into it and you realize, wow, this language has had a lot of influences, like from Haskell and Python and even Erlang. And of course, some of the best parts of C# are going to be in there. You really understand after you've been using it for a while that it's much more than OCaml. It's really not even OCaml. That's kind of a misnomer because now I understand that it's a complete re-implementation of a camel-like language. And I've heard Don Syme say that the core of OCaml is in there, but not really OCaml per se.
That's really interesting because so Don Syme then is the creator then of F#.
Yes. F Sharp started off life as a Microsoft research language. It was designed and implemented primarily by Don Syme, or originally by Don Syme. Now, there's another fellow that I know less about. I believe his name is Andrew Kennedy, and he did some early work with Don. I think he was like, there was another project that F Sharp was kind of drew from or helped based upon. It was called Generics with .NET, and I'm really not familiar with that project at all. But Andrew Kennedy and Don Syme both designed and developed that, and so I think that's at least partially how Andrew comes into the picture.
So looking at F Sharp, and then you can see maybe on the Java stack on the JVM, you've got other languages like closures, and you've got the languages like Scala and things like that. So it's very similar to that, isn't it? That it compiles down into IL, the intermediate language, similar to absolutely what C# will compile down into.
That's exactly right. Yeah.
So you can, in theory, use a bit of F Sharp, a little bit of C# in the same project, and tackling the problems that it solves really well.
Yes, you can. Yes, you can, and while I've not done that personally, I have used obviously .NET things and .NET libraries, which are easy to do from F Sharp. But yeah, most of the time I try to write just in a purely functional manner because I'm learning. I'm definitely not an F Sharp expert. I've only been acquainted with the language for, maybe 6 months. I haven't stopped to look, and then, only afternoons, evenings, and weekends. So, but yeah, I love it. It is a hybrid. It's not a purely functional language. It's what they call a functional first language. And I think what that means is Microsoft set everything up to make it easy to fall into the pit of functional success, like everything is immutable by default, so on and so forth. You can, obviously, since you can draw on .NET, you can work with objects. You can program totally object-oriented in an object-oriented fashion in F Sharp, but it is harder. It's really almost like the inverse of trying to program functionally in PHP.
That's correct. Yeah, so it's like you don't really want to do it. As you say, it's the first thing is do it functionally. Go this way. We're going to make it hard, as you say. Yeah, that's a really great way of kind of thinking about it. And so yeah, I mean, you mentioned it. It's OCaml influenced. Have you ever played with OCaml, or is it kind of you're learning OCaml through F Sharp really?
That would be the only OCaml I'm learning, because I have not tried it yet. I have tried many other functional languages since coming to F Sharp. Obviously, I've mentioned Elixir, but Clojure, for example, I had looked at and stopped looking at Clojure by the time you started getting into it. And I like it as far as it goes, but for me, it's great that we have all these different kind of programming languages, because some work better for some people than others, and all the parents just blow my mind.
Oh, good old Lisps, eh? Good old Lisps.
Yes.
I think that is one thing, yeah. It can, yeah. I mean, the beauty of it, that it's fundamentally, the data is code is data, and that, with Clojure, and all Lisps really, that, you can really, it's such simple building blocks, but the code can look quite scary when you just see the open and closes of these curly braces or these parens, and you're like, oh dear, well, this is messy. Yes. This doesn't make sense until you break it apart.
And I know a great IDE helps loads in that manner, in that capacity and ability to do that. And I never really spent the time to, go so far as to download Emacs and really get into it. I did play around a little bit with Ratchet, and I like the concepts, but I never used it long enough to get down into the type system of Lisp and things of that nature. I kind of just made a circle there and came back around to my F Sharp.
Well, I think that's great though. I've been having taking the time to look in and invest. And as you say, there's so many languages, and they're so different, and they're so great, and they've all got their pros and cons, and your own personal opinions, and then general consensus of what they are. So yeah, with F Sharp then, what are the selling points to it? Why would you? I know it's a functional first language, but
yes.
what would you use it for? Like, I suppose that's kind of one thing that people would think, like, why would I not use C# for everything?
Right. Well, one thing, C# does have types, of course, but F# is a more strongly typed language, and maybe more in that sentence is not exactly correct because I'm not a type expert, but I know for certain F# is a strongly typed language, and it has a way to extend its types. It has a type keyword, and a little something that's different from many strongly typed languages, I think. F# has a type inference, and so for anyone who doesn't know what that means, it basically means that the programmer doesn't have to decorate or document or declare their types. The compiler will figure that out for you. So it really has a dynamic language feel almost sometimes. And speaking of that, lots of people, F# does have a REPL, another unusual mark of not necessarily functional languages, but strongly typed languages. And a lot of people use F# for F# scripting. And I do not, personally. I do use the REPL for, exploratory type programming, but I say I don't use F# scripting. I guess I use it all the time with a tool called Fake. Some tools use F# scripting, and Fake is one of the build systems for F#. It's the analog or to make. It's a play on words there, I guess.
That's so cool. I don't know whether this is. I mean, so maybe it's like Haskell. Does Haskell have a REPL? I don't know whether it does, because this is quite interesting.
I do not know.
Yeah, because it's interesting that, F# you say has a REPL, and I love the REPL. I think that's one win where you get into the Lisps and things like that. You can just play around and explore.
Yes.
And see different ideas. And, people do have this REPL design and REPL testing kind of feel, where you can play around with something, seeing if it's going to work and compose it together. And especially with things like, because, I mean, I've only had like maybe a couple of weeks, sadly, of experience with F# just playing around with it. Because once I knew that, I'm thinking, we've got to get you back on the show. I was like, I really need to look into F#. So I put down the closure for a little bit, and I've gone deep into trying to understand some of the F# concepts. And the type system is just beautiful. I mean,
yes,
having a good type system. I know I've mentioned it on the podcast before, and there's this whole types versus tests thing and everything. And I think that you have both. I say, why not take both? Don't think you just have types or just has tests. And the type system is so good, and so you can mimic data, dependent types and all this, and you can have. I mean, we're going to talk about, the concept of making illegal states unrepresentable is one thing that people really want to drive. When they're using like Haskells and the really heavy type systems, is to try and make it that I can't make an illegal state. It will, it's not possible within my system. And allowing your compiler and your type definitions to really aid that and really kind of make sure that doesn't happen. It's a
concept that blows my mind.
It really is. Me too. I look at this and I'm like, I never thought of a type like this. I am very much, kind of thinking of the primitive types where, you've got your ints, floats and all this, and then maybe the abstract data types, which in our concepts are just classes, just instances of classes. I mean, that's really where I was, coming in. And then delving into a bit of Haskell and then delving into a bit of F#, and you're like, okay, there's all this. This is insane. This is absolutely amazing. Mind blown, that you can essentially just make your own types and you can create your own world. I mean, one thing that I find that F# does do, and reading some bits about it, is that it really tries to allow you to create a good DSL for your language and your problem. Have you found that?
Absolutely. One of the getting back to this whole thing of computational expressions, meta programming, and yes, you're absolutely right. Types and the whole concept of, like you said, you have types, then you have primitive types, and then abstract types, and then maybe constructing your own types. I'm just to the point where I am experienced with wrapping a primitive type to define a type in F#. And But yeah, going beyond that and actually using types to make certain states or illegal states unrepresentable, that blows my mind.
And it's crazy. I mean, I have actually seen some code where some of these concepts are actually present. Well, you can do some of these like illegal representation, like illegal state unrepresentation. That is a very badly way of wording it, but you can do this in languages like Java and things. So it is possible with the languages we have now. There was some crazy kind of tomfoolery that you could do with generics and things, but you probably wouldn't want to do that. Again, it's using the right language for the job that you have in it. You have to do. So yeah, I mean, one thing then with F# that you did touch upon is the fact that it's firstly functional, but it can do the OOP stuff. And how is that? How does it look in because obviously it's coming from the OCaml language, and I'll put some in the show notes some links to that so people can kind of get a feel for what the language looks like. And I'm just wondering, what does the OOP, I love to just saying the word OOP. What does the OOP actually really look like in this language?
It looks very similar, but just a little bit different from an object in a normal, like say C# or PHP even. You can, one way to construct an object is with types, for example. We were talking about types, so you can say like type person, and then parent name, :string, age, :int, close parent, and then equal, and then you use a keyword called member to declare, say, all of your instance variables. So like member x.name x.name equal name, and this gets back to, and then member x.age equal age, and it gets back to wrapping a primitive type. So yeah, but it is a little clunky. It looks a little,
and with these, like, because there are like the concepts of records and tuples in there, and
exactly,
and this is all immutable. Like, is it very much like the closure world where I have data structures that are by default immutable, and I can treat, understand, and so that is the same in F#. Then it's immutable.
Yes, and it's much more elegant and easy to use than an object. Discriminated unions then come into play, and you can use those to really make your tuples. And what else were we talking about?
Records.
What other kind of records? Yeah, to really fully utilize your records and tuples. And your other pattern matching capabilities that the F# language brings into play. Discriminated unions are a type that kind of gathers all those things up into one structure, and it's a common pattern in F# to use a discriminated union to not exactly wrap those types, but utilize those types in a pattern matching function.
Right. Okay. So is it similar? Because I mean, going back to PHP, we have this concept of going to be having union types where we'll be able to, and also intersect types where we'll be able to say either that or that and things like that. So is that similar there then, when you're going to be able to? That's how you're essentially on the fly making a new type. Well, you're saying it could either be one of these types and things like that.
Yes, absolutely. You have the concept of sum in F# and none, and those are utilized very predominantly when you're using pattern matching and discriminated unions to contain tuples and records and pattern match.
Well, you have actually brought it up then. You were the one that brought this up. You brought the option, you brought the sum, the none, you've brought in monads.
Yes.
Yes. You brought in the M word. And, you did mention computation expressions before, and you know what? I mean, I've tried my best throughout the years to try and understand monads and try and understand the concepts and functors and things like that. And I feel that I slowly get, a little bit closer, and then I go back and I'm like, what? And then I go back again and I look again. And for the beginner, some of the, I think the best thing to do really is to not understanding all the category theory and all those I mean, it's great to try and understand that because it's really fun and geeky, but really what can I use this for? What's the practical use case? And one you did say there is the option monad is the concept of sum and none. So, and you mentioned obviously there as well, pattern matching, which is another win in a language such as this. So how do you use sum and none?
Sum, of course, is the concept of, well, in an F-sharp pattern matching construct. And it would be better if I had one up on screen. I should have thought of that. It's kind of hard to explain.
Yeah. You can kind of deconstruct, can't you? You can. That is one thing. Finding with audio and podcasts is not the best sometimes to explain code.
Really, I guess the easiest way to say it, without getting too bogged down in the details, is it's just like it sounds. You're stepping down like a case statement through many possibilities, and you want to test for, in your pattern, some of this or some of that, and then as a analogous to the default in a case statement in PHP, perhaps none, if that's an in fact valid state, would wind up your pattern matching construct.
And pattern matching, I first learned about pattern matching in Scala. And the concept of being able to, destructure. So essentially, it is like it's a souped up switch statement, really, you can think of, that allows you to deconstruct types. It allows you with, as you say, with the sum, that I can say sum, and you're able to deconstruct the actual value it holds into a variable that you can then use within, the associated, whatever happens when that's the case. It allows you with anything, really, to be able to deconstruct these things. And we'll put in the show notes again, like some examples of this, but pattern matching is a beautiful, beautiful thing where you have these kind of, the typical thing of where you'll be doing things such as testing for types instance of this or something, and you want instance of this, and then I also want to break it apart and do something with that and all this, where you can just define it in this elegant switch-like statement. It's a really nice thing, and it's one of those things where you're like, I really wish this was in languages that I use on a day-to-day basis, because it has so much power and it's so succinct in the way that it displays the problem that you're trying to solve. It's brilliant.
Absolutely, yeah. Going back to monads for a second, and
you're bringing it up again.
I'm just beginning to get something of an understanding of one, but I think the first understanding or the first example of one in use that I looked at and understood was in an F-sharp framework. I guess you would call it a framework called Suave or Swave IO. I guess it depends on where you're from, how you pronounce that. But we'll put this in the show notes. I'll send you the link. Suave.io is the website. And it's a web framework written by Henri Jourdain. I hope I'm pronouncing that correctly. But anyway, and the definition that, I don't know if this is really correct or not, but the way I think of it in my mind is, a monad is really nothing more than saying, take these two functions, execute the first one, and take its return value and give it to the second one. And that's one of the primary patterns used in Suave or Suave when it allows when it's responding to your web requests. It's a really fantastic framework too. And you should look at that.
Yeah, I'm definitely going to check that out. Absolutely. Because it's actually really interesting where I may have I did the wrong thing of looking at monad and just Wikipediaing it and then like getting blown by the category theory kind of concepts and all that. And actually, you're like, oh God, what is this? And then you have Haskell, which, again, very much sides on the whole concept of knowing this mathematical stuff, essentially, and it really can blow your mind a bit, and you realize, I've got the IO monad and all this, and like you said, like actually to me personally, the best examples I've had are the F-sharp ones, like the ones I saw this last couple of weeks. I was like, this is absolutely like this does what I already knew by trying to decipher a lot of this kind of understanding of this complicated stuff, and learning it through computation expressions and through F-sharp really did open me up, thinking, this is great. This makes sense, actually.
Yes.
And it is true. It's exactly what there's loads of different ways, and there's so many different blog posts and articles and discussions on how to explain it. And it's almost like this, you either understand it or you don't understand it, and you have to kind of pass through the gate of understanding it. And you're like, it enlightens you, But for me, like you actually, Jimmy, it's just do that, then pass it to that. And there's for me, it's that there's a bit of indirection in between. That it does something in between.
Yes.
So, you have your function, you have something. It then will do something with that, in the background. You're kind of hiding that, masquerading that, whatever happens, whatever it does, and then it will do whatever, afterwards, or it may not. You don't know. You don't care because you just care about what you're doing,
right.
and that's exactly what the option monad for me is, because the option is some or none. So it's this concept of getting away from nulls, getting away from the checks of nulls, getting away from the null pointer exceptions, just this concept of null, which even the guy who created null says it's the $1 billion, it's the worst invention ever. But we all have nulls and we all do these checks for them, and it's codifying and declaring, an optional, saying, okay, this option, maybe fetching a user. I optionally may get back that user. I don't know if I've got that user. That's an external thing from me. I can't be sure. What you would then do typically is, how would you do it in imperative? You'd probably do a fetch. You'd either throw an exception. I can't find this guy, or I'd return null or return false or something.
Yes.
And you'd let the client then have to deal with the problem. But instead of, say, with the option, what you do is you say, I optionally could return you a user, and now the type is the type gives you, okay, it's optionally going to return me a user, so I may get a user, and it's now within it's the monads concept of having a container where the container may contain the user, or it may contain none in this case with this option monad. So what I'll do is now do application apply bind in what they call it in the monad terms is I'll say, okay, well, do this to it, in the case of, okay, optionally do, if I have to get the user, then in this case, I don't really have to do any checks to say, if the user's there or not. I just say, okay, with the user, then pass it to this, or, return it, do things like that. Or maybe with none, don't do anything or something. But it's the
don't
options.
Do anything.
That's
return
it.
a blank string.
That's
depending
absolutely
on
it.
the client or something.
That's it, yeah. And it's the options, you're essentially using the abstraction to handle that case. It now takes away the pain of that, and it's providing you with another layer, which it then deals with, and it's a beautiful thing. And actually, the F#, there was a really good F#. I think it's F# for fun and profit. Had some really good.
Oh yeah.
Had some really good documentation on it.
I'm gonna have to. Sorry, go ahead.
No. I was like, you're probably gonna say
this guy's name. I'm gonna attempt it. Scott Washlin.
I think. Yeah, I think.
Is that how you say his name?
You're better off doing it than me. I butcher names so badly.
Scott's site was the was the first F# website that I ever came upon, and boy, was that a great thing, because his site is a tour de force of all things F#. He must have the content of at least 2 or 3 books worth.
Absolutely.
In that very site, F# for fun and profit. And I have learned so much from him, and I would just like to, say cheers to Scott.
Absolutely.
Wow.
Yeah, because as you say, because he mentioned in it the CPS, it's the continuation passing style. That again was another aha moment to me, where you're essentially just you're essentially just telling it, do this next. Like, you're giving it up to the option, the monad in this case, the actual thing you're invocating, what you want to do next. Now it's up to that if it does it or not. So you could kind of think of it, and I'm bringing jQuery into, but how we typically do on success, how we deal with this. You do this, you build up these chains, and you're going to build up this, once you've done that, then do this. If you fail on that, run that instead. And you're giving the code that you're giving the action that you want to actually occur, but you don't know whether it's going to happen or not, because it's not up to you to actually execute that. And that,
every Ajax call.
That's pretty much it. Absolutely. And you have to deal with promises. that really is kind of, this is a similar sort of structure. And then that looks ugly though. And you can, as you say, you get into this callback hell. So you have things such as, like in F#, the ability with pattern matching to be able to destructure easily these kind of, sums and nones, and also actually just because it was really nice to see that again in his posts, that yeah, essentially all that actually happens is it's just syntactic sugar, some of the do notation style things that you can actually, because do notation comes from the Haskell world, but, this do kind of notation, which allows you to, really use monads, again, with the CPS style, but in a nice kind of iterative, imperative form where you're going, okay, that's it. So, yeah, I mean, how have you found using this, like the computation expression syntax?
And I have the benefit, I have to say, of not having looked at Haskell yet. So bear that in mind. I fully intend to, and I keep, I don't know, I keep playing with F# or whatever, but I haven't gotten around to Haskell yet. I've heard a lot about it, as well as Idris, another strongly typed language. And what I've heard about it really blows my mind. But back to computational expressions, and something we intended to talk about earlier, but kind of glossed over, which is like metaprogramming, or computational expressions plays a large part in that, and DSLs, and F# is used. I kind of passed by your question of how is F# used, or what is it good to use for, and many DSLs is one of the best things, or one of the most prominent things that F# is used for. Maybe not prominent, but certainly widely used for. And you can see this in the language itself, as well as computational expressions in the form of type providers. And type providers, we may talk about them in a minute if we want to, but yes, they are, in essence, they're something that automatically provides types and properties and methods on your data. So whether that's a database or even a JSON file.
This is something that you got me very intrigued with. When you sent this to me, you were like, oh, and it's, type providers have been really interested with databases. I was like, ooh, what's this? And so what actually is then a type provider, and how have you been using it? And and everything around type providers.
Oh man, they're fantastic. So everyone knows that has ever seen a Microsoft product what Visual Studio is. Ever programmed with a Microsoft product, what Visual Studio is, and its world famous tools, especially in the form of IntelliSense and dot programming. People refer to, I just have to type the beginning of a
that's it.
class call or whatever, and hit the period key or a dot, and then I get the completion. Well, you can think of, if you're trying to visualize what type providers do, that's exactly what they do, only they do it for your data. And now, to put it a little bit more technically, what F# is doing in that instance, and I really don't understand the underpinnings of this, but it's basically, you can think of it as doing type inference on your database and giving you the tools to do dot programming with the hierarchies of your data. Well, maybe that's not exactly correct, but you can think of it that
absolutely.
way.
Yeah, I would say that's a great definition of it, because, I should actually say that one thing that I thought was, I'm thinking, how is this doing? It's like scaffolding, generating all this horrible code. How is it generating these things on the data? But it's doing none of that. It's doing this all, dynamically.
That's correct.
Which is great. It's absolutely crazy. And it does, as you say, a good job of being able to, you've got a data set. Here's the data set. Please give me a nice way of being out, essentially, using that data set.
To drill down.
That's it, absolutely. And one thing, so I haven't actually had the chance to actually kind of play around with it. It's only been really kind of looking at documentation for it. But how does it deal with them with the types then? So it infers the types, or has it got the ability to work out from like different, like say JSON, different type, metadata about that, does it work out those types?
And I'm sketchy on this. I do not know the underpinnings. I'm assuming that F# uses its type inference engine to extract this these type inferences. But yeah, I feel sure that if it looks at a JSON file, that it's going to take everything in that file into account with regard to types. And similarly, in a database file, I feel sure that it knows the MySQL primitives, and so when it looks at those fields and columns and rows, that it is using that those MySQL types to translate to the best F# type match.
It's brilliant.
That's all I would say that's all I know, but I really don't even know that. I just know it's so much fun and so easy to use it.
I think that's it. And as you say, for exploring and like explorative kind of programming, being able to see what you can do with data, and having that ability to, as you say, let's use period, dot, programming, where it's like, oh, what can I use here? Oh, I can use that. Oh, I've got that, and things like that. And I mean, is this something then that's only available in F#, not available in C#?
It isn't. You're correct. As far as I'm aware, it's not available in C# or any other language that I've run across. I should give a shout out to Ross McKinley. Again, maybe I'm not saying the name exactly correctly, but Ross has been instrumental in writing many of the F# type providers, like for MS SQL, MySQL. I don't know exactly how many he's written, but I know if you go to his website, and I'll have to get you that link. He's got a ton of information on how to write your own F# type provider. And I've looked at it. It's type providers break down into two categories, and I don't know that we need to go that deep or that far off into it. But suffice it to say, there is a generative F# type provider, and you can see all of the details on his website. Yeah, I bet you would really be interested in that. But
that sounds great. I'll definitely be checking that out.
CSV, JSON, streams, APIs, XML. I can't even think of how many things it's applicable to.
That's absolutely amazing.
It is amazing.
Yeah, and could you mention the F# data? Is it that a library, or is that a...
It is.
It's a library.
And definitely include that link in the show notes, but it's on GitHub at fsharp.github.io. I remember that.
Brilliant. And so, we've got those, we've got the ability then to kind of, use these type providers and everything. And there is like another kind of going back into the computational expression world. I don't know whether you've had any experience with the either monad, using either.
No, I have not.
See, that is another one where I've been looking into it, and it's either is a great way of dealing with, say, error cases, where you want to deal with a happy path of going either do that or, okay, there's an error.
Oh, yes. I think in Elixir, which I have much less experience with, it's this is the analog, or the equivalent is the with monad.
Really interesting. That's interesting because, okay, so you've brought up now Elixir, and with
Yes.
with F#, F#'s concurrency paradigms. Like, have you had a chance to play around with the different concurrency paradigms in F#?
Just the slightest bit. As you say, there's a lot of influence from Erlang, the father of, or the predecessor of, maybe. I don't know. Elixir is really a new language, they say, but it is built upon Erlang, of course. But the whole concurrency, it's hard to say the whole concurrency model, because F# really has several different concurrency programming models, but you can see the influence in one of the concurrency models in F# is the actor model. So message queues, passing messages with two actors, and the model is termed in F# mailboxes. So anybody who's played around any with Erlang will recognize that, and will recognize the bang syntax. So let bang equal, and then you're off to the races asynchronously. So, there's a lot of influence from Erlang. Maybe, for all I know, there's some Elixir influence, but since it's come along after F#, maybe not. I don't know what the story there is.
That's really interesting that it has these different paradigms, because, I mean, is that, I don't know whether is that kind of... intentional? Like, is it kind of not a toy? I wouldn't say a toy language, like a language that all the people, all the researchers, just like, these are cool concepts that we want in a language that we can actually use on the CLI.
Yeah,
or
you know,
CII, sorry.
I don't really know the full history of F#, but it does have several concurrency paradigms. So, like we talked about that one, the actor model, and it has something very similar to C#'s async await.
And that deals with that uses computational expressions, doesn't it, as well? That's again taking advantage.
It does.
Yeah.
Yep. And so you can say like things like async dot runs synchronously and async dot await event and things like that. And it also has, and I'm really getting off in the weeds of my knowledge now, but it has some constructs for doing some reactive
functional
programming.
Reactive programming. That blows my mind. That is that is something very cool. And it's really cool that that is really a beautiful thing that on, the CLR that you can actually use a language and use these concepts,
Exactly.
It's a beautiful thing. And
split these streams, map them down.
Absolutely crazy, bonkers stuff. And what's the setup like then for F# and the tooling around it? Because you did mention Visual Studio.
Yes, and of course, there is a distinction to be made between F# and Visual F#. And I did not know this or understand this for a long time, but the Microsoft, backing up just a little bit, F# is not owned by Microsoft, and that came as a little bit of a surprise to me.
Yeah, I would think they would love to get their hands on that.
Yeah. It is an open source language. It's not owned by Microsoft. It's not owned by anyone. The F# Foundation, a nonprofit organization, helps or maybe primarily steers or guides the direction of F#. Microsoft is a contributor to F# and probably, I'm just guessing here, has an influence in the direction the language takes. But for and by large, the open source community is I think I'm correct on this, the predominant contributor code-wise, and always has been. So with that background, when you see Visual F#, that's a Microsoft product. So Visual F# tools, which by the way are great, all come not exactly out of the box. Visual F# does come out of the box with Visual Studio, but Visual F# tools are now an add-on, and I think that, so they can stay more up to date than just with every Visual Studio release. So you can install those via NuGet. But F# being open source, it has always been open source. Microsoft is a new Microsoft now. Everything at Microsoft is now open source. But F# has always been open source. It's not a recent release. So maybe due to that, I don't know the complete backstory on this, but F# is cross-platform, 100% Linux, Windows, of course, and Mac, and always has been. And that's, not a big deal now with Microsoft releasing everything and everything being cross-platform on Microsoft now. But yeah, F# always has been. So consequently, a lot of tooling has grown up around F# on alternate platforms from Windows. So like on the Mac, on Linux. And then there are some recent cross-platform tooling as well, like Atom, the HTML and CSS and JavaScript-based editor. There, in particularly, is a set of plugins for it called Ion IDE, and we can put that link in the show notes, ionide.io. And by not coincidence, I'm sure, but Visual Studio Code Microsoft's, cross-platform tooling that runs on the Mac and Linux. It also uses the Ion IDE set of plugins for F#. Of course, good old standard Vim that works with everything and is cross-platform, my tool of choice, most of the time. I will confess that I do not use it for F#. On the Mac, which is my primary machine, I use Xamarin, used to be Xamarin Mono Develop, but now, since Microsoft bought Xamarin, it's all open source too. So now I use Xamarin Studio, and it's also cross-platform. It's right, for Linux, Mac, or Windows, Xamarin Studio. You can use that to develop F#, and this world has gone completely mad in open source.
It really has, hasn't it? And it's because, so you mentioned there that F#, I think F#, didn't it come to be in like 2005 or something like that? Wasn't it really?
Yes, their first release as a part of Visual Studio was Visual Studio 2010, and that was when I can't remember the gentleman's name, who was the Microsoft employee who was tasked with, taking the open source research language and packaging it for Microsoft.
And has it always, so the F#, the language, has it always been a language that compiles down onto the CLR? Is that like it's primarily,
Yes,
job?
Right. As my understanding, yes, right from the very beginning, it was a .NET based language and did compile down into IL, on the CLR.
And so being open source, then it would always from the off then have to deal with mono and things like that. So it's always had the benefit then of being able to deal with the fact that these are just different. Because I know that Clojure was one language that, Scala actually was one language. I think it was either Scala. Yeah, Scala was one language that tried to do both, didn't it? I think. Yeah, I'm right in thinking it. I think it tried to do.
Oh, I see. I did not know that.
And they also tried, or maybe it was Clojure. I'll look back now and think, I should. But yes,
I think I do remember hearing something about a .NET version of Clojure that.
Yeah, that's it. So yeah, it was Clojure that they started on both. They thought, no, this is great, we can use both. But I think the project has really kind of taken up steam into the JVM, and I think that's mainly what Rick Hickey actually uses. So that's obviously what's got most of its attention. But yeah, so the language then F# is a CLR language, a mono language, and actually. It'd be really interesting because I'm completely out of the Microsoft world, the eco space, the whole. I mean, I'm familiar with the fact that they are very much into pushing open source stuff now. But what's the kind of story about that then? So what's now open source? What's happening with Mono? What's happening with this whole .NET core?
Yeah, I'm probably not the best spokesperson for Microsoft because I have been in the open source world for Yeah, I was strictly Windows guy and Windows programmer up until around, from back forever until around the year, 2004-ish, something in that. And then I went over to the open source side, or the dark side, as the Microsoft people would have said back then. The light or the dark side,
either way, wherever you're talking to.
And hadn't looked back at Microsoft until maybe a couple of years ago, and I'll take a swing at it. For whatever reason, perhaps because they saw their developer share deteriorating or whatever, Microsoft obviously decided consciously at some point to really take open source more seriously, and now they have gone so far as to release. Let me see. All of their compilers? Yeah, I think so. The C# compiler, the F# compiler, not just the managed code compilers, but the new versions of the C# compiler like Roslyn, which compiles down to native, is also open source. This is the next version of the C# compiler, which I understand is really almost complete and can be run today on your machine quite well with very few, if any, seg faults or whatever. But and not only that, but all their frameworks, almost the whole .NET ecosystem. it would probably be easier to list the things that
they haven't done yet.
They are not open sourcing. They're not open sourcing Windows, the OS, the Windows specific parts, I should say. Obviously, .NET is a part of the OS in the sense that that's what you develop apps with. But, the whole .NET framework practically.
That's amazing. I mean, that is a complete shift, isn't it, of what they, have been doing for years.
Yes.
And so now that, I guess, because when Mono came about and Mono, was there any help from Microsoft on the Mono project before? Was there any kind of, oh no, hey, this is great that you're, I mean, I'm sure they weren't thinking that. They were like,
yeah, I remember when Miguel came out and said, we're going to do an open source implementation of the .NET platform. I mean, like, boom,
yes.
from zero, from scratch. And my understanding is, in the early days, no, there was no help. And maybe...
That must have been so hard. That must have been...
Yeah, just think of the amount of code they had to write. And there were, 10, 12 guys, not even that many at first, versus the gigantic Microsoft.
That's it, the secrets they hold. Yeah, trying to kind of reverse engineer what actually happens. Yeah. It's a crazy project.
There was a good spec. It wasn't open. It was a published spec. So Miguel could work from that, but still, implementations are going to be different. Now, interestingly enough, I've heard Miguel say, and I really wasn't aware of this, with the purchase by Microsoft, that Mono is more a client-focused .NET implementation, whereas Microsoft's is a more server-centric. And so there are good parts to be had on both sides of the coin. And so, like, the day that Microsoft open sourced .NET, my understanding is, for example, the Mono team said, find the garbage collector, baby. That's what we want. We can't make ours as near as performant as Microsoft's. And Microsoft similarly was saying things like, hey, look, well, of course, Mono has been open source, but Microsoft was able to also benefit from that relationship, obviously, with Xamarin Studio, Xamarin Forms, and the customer base.
So neither of them because it would have been a horrible thing to think, yeah, Microsoft comes out with the product and now your Mono can go away, and it's like, oh, really? So it's nice that they're living together. They're both sharing, each other, helping each other out.
Yeah. In fact, I've heard Xamarin employees state and Microsoft employees both state that, hey, Mono will be around for years, for that reason that we were just discussing, and for other reasons as well.
Oh, that's that's a great thing, because I have, played with Mono in the past with like C# and stuff. So it's nice that work is years of work and hours of work gone into this. So yeah, it's great that it isn't just going away because Microsoft decided, oh no, we'll use this. It's like, oh, Unix systems and all this, they're quite an interesting thing. Maybe we should be able to put our platform on there. And it's like, yeah, finally you decide, to do this.
Yeah. This is, not like the Microsoft of old, where this would have been just another embrace and embrace and extend. I forget the saying, but yeah, that was like the kiss of death. When Microsoft bought you back in the dark times, we'll call them. They would buy you and you would disappear.
That's it. Goodbye. It's like, yep, your product now has got any competition. They'll be like, goodbye. I mean it's great that we live in a world now where we have this choice, and we have the choice of languages, the choice of compilers, the choice of SLR to CLR to the JVM to all these languages, and then moving on. Then so we've got the Microsoft product, and then you have you touched upon Erlang, Beam, and Elixir. So what experience have you played? What have you been doing with Elixir then?
Wow. Working through the tutorial on the website and
mind being blown.
Yes. Oh man. Trying to really grasp the concepts of their model as it relates to, it is the actor model, but they did not know that when Joe Armstrong and Robert Verding did not know that when they were developing it. The actor model was around, but they came up with it completely and separately on their own. And the actor model was just as in just barely around at that time. I think one of your countrymen, I can't remember his name, had maybe already published that. At any rate, boy, the whole concept of a supervisor tree, managing processes or actors, and working off of messages, working via messages, is obviously a very powerful model. I mean, God, when you think that you can run Erlang on a Raspberry Pi and ramp up to literally hundreds of thousands of instances, processes, all executing simultaneously and separate processes. And I think what the average size of a process in Erlang is 2K, and so by extension, Elixir.
Mental. Absolutely insane.
It is. And how you have to think about program design, and, that's something else we didn't talk about in F#, but functional program design, that is the same when it comes to Elixir, and that it's functional, as it's a functional based language, but still it is some very different thinking even between F# program design versus Elixir or Erlang program design. It's still very different. Elixir and / Erlang, they are in a category unto themselves.
And they're almost think. Absolutely, and they're almost like the true OO, aren't they? Objects, where you have these objects that just pass, messages, and they're immutable messages, and there's no concept of state within these messages just go along. Exactly. And I do feel kind of swaying back to then the F# talk is mailboxes is a great way of kind of thinking about them. I'll put here you go, here's something that you can look at, pick up whenever you need, and act on it, and that's it really.
Yeah, well put. Here's your message.
That's it. Yeah, and
take that and run.
Absolutely. And I think we're almost at the hour mark here, and one thing I would really like to kind of we've been talking about all these functional languages, and you did just allude onto it, actually. It's like kind of the thinking functionally. And we actually spoke about it a little bit at the beginning, where we were kind of like, you can kind of think functionally in these, OO languages that we use day to day. But how has it really changed the way you think? Like when you're writing an F# program, what is so different to, obviously the syntax is different, and some of the cool, we've talked about pattern matching, we've talked about the monad, but fundamentally, what changes? What way, you're solving the problem changes? Fundamentally,
for me, the biggest shift was to think of solving problems in terms of data transformation. Forget about modeling things with objects. Forget about message passing even. And think of things strictly in terms of data in and data out. And the only thing you have between those two, design-wise or thinking of it, is a function. So taking a function and transforming your inputs to your outputs, also known as deconstructing, but it's I have to say that's the best improvement I'm able to carry back to the PHP, to the object-oriented world, is problem deconstruction.
Yep. Breaking up a problem into small bits and tackling those little problems. And because as you said, with the input output and having a function in between, and that function should be referentially transparent, where, the same input that I put in will always give me the same output. So in theory, I could replace, the function, the in and the function with just the output. And these languages are great at that because they give you data structures that are immutable. So they give you things that don't have side effects, and I now think of that where pass everything in that you want in the parameters and return something. Don't have magic, with this and stuff. One thing actually, it was a while back actually on the Functional Geekery podcast. Someone spoke about the fact of, one way of thinking about this is having just, they were from the JVM, so they were from the Java stack, of just having, because we were very lucky in PHP where we have first class functions, of just having classes with static methods. That's it.
Yeah.
Have static methods.
Static
everything
methods.
Everything comes in through the parameters, and you get something coming out. And you know that everything you need comes in there, and it makes testing so much easier because the setup process is just those things that you're coming in, and you'll be able to do the whole thing. The whole good coding thing where you're like, oh, actually, this has got too many parameters. This is dealing with too many things. I need to break it up. Still, you get the sync responsibility. You'll still get these feelings. But only thinking in functions and transformations of those functions is a beautiful thing.
Yes, and it really is. And until I had done this type of programming, I always, it's hard to say, but object-oriented programming really is, it looks a lot like spaghetti programming after you've gone and done even a little bit of functional programming. I mean, you got messages flying all over the place.
You got state everywhere.
You got state everywhere.
Absolutely. And newing up all these. Yeah, absolutely. It does. It is amazing how something that, when you learn OO and you think, modeling, people actually say, and I think wrongly say, you're modeling the real world, because really you're not. You're modeling the problem that you have. Modeling the real world is actually a really bad anti-pattern, I feel, because you can't think that way.
You don't want to do that.
That's it. You don't, and you've got a car with wheels and all this. It's like, well, obviously that's a very trivial example that they say modeling the real world, but, you're modeling the problem at hand with objects, and it has got some very nice things to it, and again, it's got its pros similar to any paradigm. But yeah, when you go into the world of functions as first class, and that's it, functional, and you don't have state, and you're not newing up instances, you're not creating these classes, you're not creating this hierarchy of objects that you have to kind of work out and understand what's going on, and you've got all these design patterns around it, you've got all it really takes you back to, it simplifies your thinking.
Simplifies it, yes.
Yeah, it really
does. And it does make it, even the little bit that I've done, it's clear. It does make your code easier to reason about.
Absolutely. And thinking of, especially in languages then with like F# and Haskell, I found that you think in types and you think of type transformations.
Yes, you do.
And that way of like, okay, well, I don't actually, I mean, some people, and this is absolutely crazy, is that they don't even think, they just think of, okay, what functions do I need in the form of just type declarations, where I need something that will transform that to that, that to that, that to that, and then they'll, build up from there. And that to me is absolutely kind of decomposing the problem into its most fundamental parts, and it's an absolutely great thing.
It's exactly backwards from the way a traditional OO problem decomposition is done. Well, maybe not all OOs, but PHP, certainly. We don't sit down and think about types.
No, absolutely not.
How am I going to solve this problem in terms of types?
Absolutely.
Whereas Idris, I understand, on the other hand, you define the types, and to a small degree, it can write the function for you based on the types.
Absolutely correct. I mean, that Idris is one of those languages that is on my list. I've listened to a couple of talks and looking at dependent types and all. I mean, a dependent type to me is mind blowing. And I know that you can actually, I think you can kind of do it in F#, where the concept of a dependent type is it's something, that is dependent on another thing, which in the case of one of the trivial ones they give is in the sense of a vector or an array, where the append is, whatever I currently have, plus whatever I'm adding to, the value must be that length, or something. So you're encoding in the type the fact of this, this property, this invariant that must occur, that this, the characteristics of that, where we don't get that with interfaces. I mean, I've banged on about it so many times with like stacks of what, you have an interface called with a stack and these functions, but you're not really defining the behavior of what really a stack should do and things within that. And having that ability to do in the types is so powerful.
Yes, it is. Something else I heard about Idris that I actually understand is how they think in terms of a function taking in one type and returning another. That's the purpose of the function, is to return a different type and maybe create that type dynamically. And the trivial example that they give there is something that any C programmer is familiar with, and any PHP programmer, and it's printf, and how you provide a format string and you provide a type, but you return, that's a function, and it returns a different type. So you might pass in a decimal and print it as a string.
That's a really good way of thinking of it. And that does actually, with that invocation of that, like one thing that F# does heavily kind of use, similar to Haskell, is the kind of concept of of currying, essentially, of this concept, where every composition and the function, a function has one parameter. Even though you may have a list, essentially what it is it's just a curried function, which one parameter then returns another function, which then has an RT, of one less, where it's like, I need another, parameter, and eventually it will return your, what you actually want. Yeah. So that allows you to have this partial application free out of the box. You don't have to explicitly say, I want currying or anything. Out of the box, you get F#. In F# or at least, some of these first, very functional languages, is you just get the ability to be able to say, in the case of having an add function, I would like an increment function. Well, add one to it. Add. This is it.
Add one, yeah.
And you have this, ability to be able to say, okay, well, I can compose that function out of this function I already have, because it's just, partially applying it, currying it, with providing one of those already. Yes. And I mean, the real kind of sorry, you go on.
No. It's such a simple concept, but yet it was something that was so mind-blowing to me coming to functional programming, because I'd never heard of currying. The thought of having a function that you didn't have to pass all the parameters to. Oh, and it still
actually
works.
Yeah, that's it. It returns a function that, of this brand new function, essentially, that has one less. And yeah, I mean,
that wasn't enough. Oh, you mean I can pass in the rest of the parameters later and it still works?
Without having to, I mean, then again, in the OO world, thinking I would have to make a whole brand new concept. This wouldn't be the case. I would have to now, up front design each individual one with a parameter less and things like that. So
yes,
yeah, it's a really beautiful thing, currying. And languages like JavaScript and they do allow you to do this. Like they're and even with PHP, you can go around kind of abstracting on top of it. Again, F# and languages like that and Haskell, they out of the box give it to you, so they're going to give you a much nicer fluid interface for that. It's going to look a lot nicer in those languages. But the concepts of currying, I mean, currying is a technical thing of trying to simplify, really, and it really does, because if like you mentioned, having one I provide one argument, I return one argument, or I return one parameter, and I return one thing, and that one thing can essentially be a function, which is then with the partially applied function, which in our case of the add one is just an add one function that you then provide another integer to or value to, and it'll increment that. Or in the case of a real value, I mean, some people do go into the whole thing of, well, you can essentially, a type could be a tuple, because you could have a tuple which has multiple things in. So,
and that's true.
And that's so you can take advantage of it that way. But yeah, thinking in just one type, like one thing, not having parameter lists that are infinite, just having this, and creating,
simplifying. Yeah.
That's it. And having building blocks, where, one thing actually I do find in the functional world where what I've taken back is really, how can I, what are the base things that I can use, and how can I reuse these, and how can I, essentially like the addition, or so, these things where you have the base, and how can I make functions from other functions, composing functions together to create new functionality, because you really can do that. You don't have to reinvent the wheel. I mean, things like Clojure, where Clojure, everything which you don't have to reinvent. You're using, like, say, a map and a list and stuff, and you can use a source on it, and everything can use a source, and you're using these generic things that are already being solved for you, these common pattern data structures, as opposed to in the OO world, where you're going to be like representing a user, and you're going to be adding the same functionality again in another place.
That's right.
It's mind blowing that we do this, but we do on a day to day basis.
It really is.
It's a very funny thing where in the world of OO we feel, oh yeah, but it's just domain specific, and but then in, say, in the Clojure world particularly, I find that I'm thinking of, okay, well, I'm using a map here, or I'm using a list. These are these, I can use these, and I can use them everywhere, and they're ubiquitous, and everyone understands them. And I before I'd be thinking, oh, this is horrible. You just why don't you use something that's very specific? You don't need to. Like, you can use these fundamental concepts and have functions again that just pass these in and return new state, new results.
Yes, and one thing you said right there, Ed, made me think, what all was I bringing back to the op or side of life and from functional programming, just the functional programming, sure, the concepts, but even the usage of the constructs built into the language, like map, like reduce, like whatever they might be in your language of choice, like in PHP. The syntax is a little wild, but yeah, you don't have to write a for loop every time you want to work with a collection. And not only do you not have to, but you're going to be yards and yards, or I guess as you would say in the UK, meters and meters ahead if you don't. And if you instead use functions like list, map, reduce, filter, those are simple, but really big wins.
Really powerful, because they're problems that have been solved all the time. And the concepts are, you again, when you then start thinking of a map, a map's characteristic is it's going to go through every, item in that list, in that sequence, whatever, applying this function to. A filter is going to filter out things from the list and only give you something that's maybe the exact length, or maybe less than what you already get passed in. A reduce is mind-blowing. It can really compose any of these things, reducing a value from one value to another. But these higher order functions, these higher order concepts, they, as you say, remove the whole need to have this imperative mindset of going through an I++. Why?
Yes.
Why do we do this anymore? We don't need to.
Is it in or is it in -1?
That's exactly it. Yeah, absolutely.
I'm working with a collection of 10. Do I put 10 in the for loop, or do I put 9 right here?
It's absolutely. It's these things which we've kind of just taken and really thought this is what we just taking as this is fact. This is what we have to do.
Yeah.
And it's just
Is this a zero-based array, or is it? It's just so many,
absolutely,
so many instances where you're just going to win. I like that expression I've heard so many people use with functional programming. It makes it easy for you to fall into the pit of success.
I think that is a perfect way to end it, Jimmy, because thank you so much again. I could talk to you for hours. I really could. But
so could I.
But I think, what we'll do then, is we'll definitely have to do this sooner than a year. But though audience, it's been another great episode. Jimmy, again, thank you so much for coming on, and we'll speak to you again next week. Goodbye.
Bye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.